Hello everyone! Well, today's video is being created on January 13th. So we have this number 113, right? January 13th. Well, I think today's date, 113, is really cool. Why is that? Well, 113, it is a prime number, okay? Maybe not that interesting. I mean, there's lots of prime numbers and probably lots of different dates which can be represented as primes. But what if you take all the different ways in which you can arrange the digits that are in 113, so 113, and how many different ways can you arrange those digits to create other numbers? Well, we can take 113 and we can arrange those digits as what? As 131, right? Well, that's actually a different way to write the date, right? This here is the month-day format, and here would be the day-month format, which actually most of the world actually uses. Are there any other ways to arrange the digits? Yeah, I think we can go 311. Okay, and I think that should be all the possible ways in which you can arrange the digits of 113. Okay, so 113 was prime, while 131 is also prime, and 311 is also prime. Huh. So it's prime in no matter which format you write the date in, and it's prime in any possible permutation or any possible way in which you can arrange the digits of the number, and any number you get is also prime. Well, when that happens, what we say 113 is a permutable, a permutable prime. A permutable prime. So that's kind of cool, but, well, how many permutable primes are there? Well, the sequence of these numbers, most people say that it begins with 2, 3, 5, 7. Now, here, I mean, these are all one digit, right? 2, 3, 5, and 7 are prime, but any permutation of it, I mean, it's only one digit, so you can't do anything to it. So it remains itself, and of course, it'll still be prime. So not very interesting. The next number would be, well, 11. But again, here 11's prime, and you take, well, you either have 1, 1 or 1, 1. So again, not very interesting. But then I think the next digit would be, the next number would be 13, right? Because 13 and 31 are both prime. And then I believe we have 17, 37, I think 79. Okay, and then, well, the first three-digit number, which is prime and is a permutable prime, is 113. 113. So there it is. So there's our date, and it's the first three-digit permutable prime. Okay, kind of cool. But how long does this sequence go? Well, I think the next permutable prime after 113, I believe it is 199. Okay, 199. Well, that's beyond, I mean, that you can no longer represent as a calendar day, right? So the only three-digit permutable prime that can be represented as a calendar day and is prime in no matter which way you represent it, in month, day, or day, month, is 113. So that's kind of cool. Well, one more. What about if we look at, so today, okay, it's January 13th, but what, so 113, 3. But what year are we in? Well, we're in 17, right? So 1, 1, 3, 1, 7. Well, this number is also prime. Wow, that's really cool. Now, the question you got to be asking is 1, 1, 3, 1, 7 a permutable prime? That's a great question. And, I mean, we don't even know yet, right? How far does the sequence go? You know, I mean, you'd assume it goes beyond 199, but what is the next number? And the next number in this sequence, I'll tell you right now, is, well, I don't know. I don't know what the next number in the sequence is. And, you know, is this some finite? Is there some number which is the biggest number, the biggest permutable prime? Or is it infinite? That would be a great question that right now I can be honest and say I do not know the answer to that question. And I also am not sure about, is 11317 a permutable prime? We can look at this and say, well, there's no 2 in this number, right? Because if there was a 2 in here and you took all the permutations, well, then you would have a number that ended in 2. And if it ended in 2, then it has to be even, and therefore it cannot be prime. And same way if it ended in a 0, it had to be even, right? And it could not be prime. If it ended in a 5, it would have to be divisible by 5 and could not be prime. Well, there's no 2, there's no 5, there's no 0, right? There's 3 ones, a 3, and a 7. So this is, I mean, I would say a possibility for also a permutable prime. And how cool would it be if it was a permutable prime? And I'm probably just going to leave it with you and something to think about. I mean, you know, it shouldn't take you too long to take all the permutations of 11317 and then look into, I mean, are those permutations prime? And if they are, wow, I mean, that would be, this date would be, I think, monumental. But at this point, is this a permutable prime? And the answer to that is right now, I don't know. All right. Well, something to think about, and I'll see you guys soon. Bye-bye.